Hi everyone, welcome back to the channel. Today I'll be covering converting recurring decimals to fractions and from the numbers chapter of IGCSE Mathematics. So first I'll cover a few examples and state some basic rules and then follow up with other practice questions. So before we start off, it's best to understand how exactly the places of decimals work. So let's say, for example, we had a number 218.345. Okay, so on the left hand side you should know that this is the ones place, this is tens, and this is hundreds. After the decimal place, this is known as the tenth place, this is the hundred, and this is the thousandth. So from the left hand side, starting from the rightmost, it's ones, tens, hundreds, thousands, and so on. But after the decimal place, starting from the left hand side to the right, it goes from tenth to hundredth to thousandth, and so on. They all end with th. So to start off with a very simple example, many of you might be familiar with the recurring decimal 0.6. This dot at the top represents that digit is what is constantly repeating. So if you see this number, it means 0.66666 and so on. Now, the way to convert these recurring decimals to fractions, what you will have to do is in the numerator of the fraction, write the digit that is repeating, and the denominator will always contain the number 9. But the number or the number of digits of the number 9 depends on the number of digits repeating. In this case, only one digit is constantly repeating, therefore we only have 1 9. And you'll realize that 6 by 9 can be simplified to 1 by 3 because they're both divisible by 3. And when you type this on your calculator, you'll see that you'll get this answer, 0.666. And 1 by 3 is the more or the common known form of 0.666 and so on. And now another simple example would be 0.7 recurring. So this again would mean 0.7777 and so on. And with the same explanation or steps I mentioned above, you have to write the repeating digits in the numerator. In this case it is 7, and you have to write 9 in the denominator, and the number of 9s depend on the number of digits that are repeating. In this case only the digit 7 is repeating, so that's a single digit, and therefore we have only a single 9. And this cannot be further simplified to anything. If you type this on your calculator again, you'll see that 7 by 9 is actually 0.77 and so on, recurring. So from these two examples we can deduce basic rules. The first basic rule is that the repeating number or the repeating digit is in the numerator. The next one is the denominator is always 9s, or it always contains 9s. And the third one is the number of 9s depend on the number of digits repeating. Okay, so let's apply this rule and move on to a few more complicated examples. So let's say we're given the number 0.53, and you'll see that both of them have these dots at the top. That means the digit 5 and 3 are both constantly repeating. So the recurring decimal would look like 0.53, 53, 53, and so on. And following the basic rules I've mentioned above, we would put the repeating digits in the numerator, and the number of nines in the denominator would depend on the number of digits repeating. So in this case, there are two digits that are repeating. So we would have two digits of 9. Basically, we would have 99. And you realize that this cannot be further simplified, so you'd leave the answer as it is, 53 by 99. If you typed on your calculator, the calculator would show the decimal form of the answer as 0.535353 and so on. Now for the next few examples, I suggest you pause the video and attempt it yourself and see how it goes. So the next question we'll be doing is 0.152 with the dots on 1 and 2. This means the 1 and the 2 are repeating, but also everything in between, which is 5. So like let's say if we had 0.1234 and the dots were on 1 and 4, the recurring decimal would basically be 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. So continuing for this question, in the same way, the digits which would repeat are 1, 5, 2, and the number of digits repeating are 3. Therefore, we'd have 3 nines in the denominator, so it would be 999. And I believe that can no longer be, cannot be further simplified, so we'd leave the answer as this. So far all of the questions we've done, it was always the first decimal place or the 10th place where the recurring decimal would start. Now for the following examples, we'll have it in the case where it is not the first decimal place where the recurring decimal starts. So let's say we have the number 0.02 and 2 being the recurring part of the decimal. So this would basically be 0.02222 and so on. So before we move on with this question, one thing you should be aware of is how to change the decimal places. So let's say for example we had the number 0.2 and I wanted to change it to 0.02. I would have to divide this by 10. And if I had 0.02 and I wanted to change it to 0.2, I would have to multiply it by 10. So the reason why it's 10 is because I'm shifting the decimal by only one digit. If I shifted it by two digits, then it would be 100. And what you should remember is that from the bigger number or the lesser decimal places to the more decimal places, I'd have to do division. From more decimal places to lesser decimal places, I'd have to do multiplication. So you should probably keep this in mind. Now, in this case over here, 0.02 reoccurring can be written as 0.2 recurring divided by 10, according to this over here. Now I know how I can write 0.2 recurring in a fraction. So because 2 is a single digit, that is the recurring part of the decimal, I can write 2 in the numerator, and simply because there is only one digit that is constantly repeating, I will only have a single number 9 over here. But to complete it further, we would also have to write divided by 10. So when you put this together, this is essentially 2 by 90. And this can further be simplified to 1 by 45. And if you type this on your calculator, this is the recurring decimal you would get. Now let's move on to a more complicated question. So let's say we're given the number 0.0305. Now this means everything between the 3 and 5 would be repeating. So essentially the recurring decimal would be 0.0305, 305, 305, and so on. The same way as last time, we'd write the part of the part, we'd write in the same way as last time, we'd write the decimals that are repeating in the recurring part of the decimal is the numerator, so we write 305, and the number of nines would depend on the number of digits repeating, and in this case it is 3, so it would be 999. But you should notice that we're dealing with 0.0305 and not 0.305. So in the same way as question number 5, we would have to divide this by 10. And if you simplify this, you'd see that would be 305 upon 9990, and that can further be simplified to 61 by 1998. I hope you understand that the reason why I'm dividing by 10 is because I need to make 0.0305 look like 0.305. Now the way that's possible is if this was multiplied by 10. So obviously if I had to write this first, as in 0.305, I would have to divide it by 10 to make it 0.0305, with 3 and 5 being the digits which have the dots on top of them. So in the same way, let's move on to another example. Question number 7. Let's say we're given 0.0035 with the dots on 3 and 5. That's basically 0.00353535 and so on. Now I need this to end up looking like 0.35. And the way I would do that is if I multiply this by 100. So if I wanted 0.35 to equate to 0.0035, I would have to divide it by 100 to give me 0.0035, because I'm doing the opposite in this case. So now that I've done this part, now I have to change this 0.35 to its fraction form. 3 and 5 are repeating, and because they're two digits, it would be 99 and divide by 100. So this would basically be 35 upon 9900, and that can further be simplified to 7 upon 1980. Now let's move on to the last question, which is a bit more complicated. Let's say we're given 0.42 with 2 having the dot on top of it, meaning 2 being the recurring part of the decimal. So it would basically be 0.4222 and so on. With all of the examples we've dealt with so far, the recurring part was always right after the decimal, or it would contain zeros between the decimal place and itself. In this case, we have another number. So we can actually break this 0.42 down into smaller parts, which would be 0.4 and 0.02 with the dot on top of 2, because 2 would be the recurring part of the decimal. Now 0.4 can remain as it is for now, and 0.02 is what we would have to convert in the fraction form first. Now, because the 2 isn't right after the decimal place, I would have to write it in the form where it is. Basically, I would have to write it as 0.2. And the way I would have to equate 0.2 to 0.02, I would have to divide it by 10, as I've mentioned in question number 6, question number 7, and I think also question number 5, because that would give me 0.02. Now I can write 2 in the numerator and 9 in the denominator and divide by 10, obviously. Now 2 upon 90 is what it becomes, and then we have our 0.4 to it. Now we can convert the 0.4 to a fraction as well. That would be 4 by 10 plus 2 by 90. And with fraction addition, you'd have to make the denominator the same. So I would multiply the numerator and the denominator by 9. And then I would get my final answer is 19 by 45. So basically what we did over here is apply all of the rules we learned previously, but we further broke down our what looked sort of complicated decimal into parts we were familiar with. I separated the 0.42 to zero point 0.4 and 0.02, and then I converted each of them to their fractions, and then I simplified them. And that's basically how you should approach every question in mathematics. For example, even if you work with compound shapes, you're expected to break the shapes down into shapes you are familiar with, and then apply those respective formulas to it. So that is it for this video. I hope it makes sense. If you have any questions or doubts you would like clarification with, you can leave them in the comment section below. You can check out our other videos regarding the numbers chapter in our playlist, and I hope this video makes sense. If it helped, consider liking and subscribing. I'll see you in the next video. Thank you.